Hello, and thank you for joining me for our first unit. We're going to be talking about astronomy. So today we're going to talk about the planets specifically and a little bit about the solar system in general. So at the end of this, you will be able to list the planets in order, starting at Mercury, ending at Neptune. Use characteristics to describe and identify planets. You'll be able to compare and contrast terrestrial and Jovian planets, which we'll talk about what these terms mean shortly. You're going to describe how solar and lunar eclipses both occur, and so differences between those. So let's get started. For starters, at the center of our solar system, we have the sun. And our sun is the brightest star we can see in the sky. As far as size goes, approximately 1 million Earths. So if we took Earth and multiplied it 1 million times, could fit inside of the sun. So it's not small by any stretch of the imagination. But as we'll learn later on in the unit, it's not super big either. At the center, so at the very center here, I need a new color. The very center here is helium. And so on the outside we have fusion taking place, so hydrogen atoms are colliding and they are coming to the center to form helium, and that's what's in the middle of the sun. These dark blotches, these dark patches here that you can see, lighter colors, are areas of cooler energy, less energy. Cooler temperatures are found here. Now we're talking cooler, not talking super cool by any means. We're still talking the sun, so it's still going to scorch you, but just not as warm as these brighter light marks that you can see there. And then the last piece is roughly 4.5 pounds of sunlight hit the Earth each second. So if light had mass, which according to Einstein's equation E equals mc squared, it does. So E is energy. We can measure how much energy reaches the Earth each second. We know C. C is the speed of light, which has a value of 2.998 times 10 to the 8th. E means times 10 to the 8th meters per second. So we can figure out how much mass that would be. It would be about 4.5 pounds striking the Earth each second. All right, our solar system as a whole is made up of 8 planets, which we're going to look at. The 4 inside the asteroid belt are called terrestrial planets. And those beyond the asteroid belt are called Jovian planets. So terrestrial meaning solid or Earth-like. Terrestrial refers to Earth or solid or planet. So these are the solid planets that we have. And then Jovian planets are also called the gas giants. So they are made of, you guessed it, gas. All of these revolve around the sun, which is our source of light and heat. And then it's the sun's gravity, which keeps our planets in orbit around it, which is really important, otherwise we'd be flying off into space, going who knows where. So let's get started. Our first planet is called Mercury. This is our fastest planet. So Mercury is closest to the sun. It's a little bit bigger than the moon. So if we took the moon and put it by the sun, we would have essentially Mercury. It's covered by dust, rocks, and craters. It has no atmosphere because the sun vaporized it all, blew it all away. So it's just like our moon, essentially a solid chunk of material going around right next to the sun. It takes 60 days for Mercury to spin one time around its axis. So for it to spin all the way around, it takes 60 days. And when the side's facing the sun, so this side here can reach a high of about 800 degrees Fahrenheit. And the dark side of Mercury over here can reach a low of about negative 300 degrees Fahrenheit. So that's quite a discrepancy between high and low temperatures there. And that's because of the lack of atmosphere. Our next planet is Venus. And Venus is actually hotter than Mercury, even though it's farther from the sun. And we're going to talk about that in a second. But it takes longer for Venus to spin around its axis than it does to revolve around the sun. So one day is longer than a year on Venus, which is pretty crazy. But a day is longer than a year on Venus. It's about the same size as Earth, so it's kind of considered Earth's twin. It's very similar in size. It has mountains and valleys just like Earth does, and plains. But what Venus also has is a super thick and dense atmosphere. This is why it's the hottest planet. So the temperature is about 840 degrees Fahrenheit. And that's because of this super thick atmosphere. And it contains a lot of sulfur as well. So when it rains, it actually rains sulfuric acid. And there's no water because it's 842 degrees Fahrenheit. And life as we know it can't survive here because we can't live in this. That's way too much for us. Only rocks can handle that temperature and pressure. Moving on, this is our planet. This is Mother Earth. 70% of our surface is water, 30% is land. If you think about us as a human, we are roughly 66 or 70% water as well, with 30% solid material. The reason we have seasons is because, whoops, that's a vertical line through Earth. Our axis is actually here at 23.5 degrees. This is why we have seasons. It's not because of distance. We are actually closer to the sun in January than we are in July. Which seems backwards, but because of this tilt, we're getting indirect sunlight in January and we're getting direct sunlight in July. That's what causes our seasons. We're the only known planet with life, as far as we're aware. The Earth is about 5 billion years old, or almost 5 billion years old, and the center is solid. So we have, at the center we have this iron core. Surrounding that we have a liquid iron core, which gives us our magnetic, that's why we have our magnets work, our compasses work is based on magnets, magnetic properties inside of Earth. And we're the only known geologically active planet in the solar system, meaning we're the only known planet to have things like volcanoes and earthquakes occurring there. Alright, planet number 4 is Mars. Mars is the red planet. It has a lot of iron, that's what gives it this red color. It has the largest volcano on it. So at one point in time, Mars was geologically active. This volcano is called Olympus Mons. It's the largest volcano in the solar system that we are aware of. Mars also has seasons because it also has a tilt, but the average temperature there is negative 67 degrees Fahrenheit because there is no atmosphere at this point in time. So that is an issue with going to Mars. If we want to live on Mars and colonize Mars, we need to create an atmosphere to increase that temperature. Really quick, take a second, answer these questions. These 5 questions. When you've done so, hit play again on the screen and I will continue with the instruction. So our next planet out from the sun is Jupiter. So after Mars we have the asteroid belt. So it goes Mars, asteroid belt, and then we have Jupiter. So Jupiter is our biggest planet. We could fit over 1,000 Earths into Jupiter, which is pretty nuts. But Jupiter is made almost entirely of gas. So all these colors you see are different gases. One thing Jupiter is really known for is this red spot in the middle. This spot right here is just called the red spot, but it's a big storm that's raged on Jupiter for about 400 years. So imagine a 400-year storm. That's what's going on at this location. Along with that, Jupiter also has actually rings going around it. Not very many, and they're not very thick. So it takes a lot. You need a telescope, kind of a nice telescope to be able to see that. But Jupiter does have rings going around it. Out of all the planets, Jupiter has the most gravity because gravity and mass are proportional. So mass is proportional to gravity. So if you have more mass, you have more gravity. So Jupiter has the most mass, it's the biggest, being it has the most gravity as well. If we were to stand on Jupiter, so if we could stand on gas, you would weigh about 3 times as much as you do here on Earth. So I weigh 180 pounds on Earth. I would weigh about 540 pounds on Jupiter, which is not good for me because I wouldn't be able to stand up. But moving on, we have Saturn. Saturn is the second largest planet, so right behind Jupiter is Saturn. One of the things Saturn is known for are these rings. So Saturn's rings are actually made of moon pieces. So moons were had collided with asteroids and different particles into space a long time ago, and then they just continued in their path in pieces, and that's where we get these rings from. So the rings aren't solid as far as a continuous band, but they're pieces of moon. And even amidst that, Saturn still has about 24 of them that are continuing to go around outside of what's in the rings. A year on Saturn is about 30 years on Earth, and the distance from Jupiter to the Sun and Saturn to the Sun doubles. So we have the sun here, we have Jupiter here, and Saturn would be clear out here. So it doubles the distance between Jupiter and Saturn, which is pretty crazy just because there's nothing in between those two. Our next planet is Uranus. So Uranus takes about 84 Earth years to orbit the sun. So when you turn 84, Uranus will have gone around the sun one time since your birth. So if the sun is here and Uranus goes this way, if you were born with Uranus here, when you turn 84, it will be about right there again for the first time since you were born, which is crazy. It also rotates on its side, meaning if this is the planet, which is the planet, the axis goes through like this and it actually rotates this way, end over end. And if we could see the moons, they would also go this way, which is pretty nuts to think about. So think of spinning a ball that's got water on it, and the water drops flying around would be like the moons. And then the last thing, this pale blue color is caused by methane, which is dominant in the atmosphere for Uranus. All right, our last planet is Neptune. There are times that Neptune actually orbits farther from the sun than Pluto does. There's instances where Neptune is farther away than Pluto. So this is our most distant planet in the solar system. It was discovered a little over 160 years ago. And it takes about that time for it to go around the sun once. So it's only gone around the sun about one time, a little more than one time since we first discovered it back in 1864. Along with that, it also has the strongest winds. And so Neptune, this image doesn't show you, but Neptune has a blue spot. So imagine if this was actually Neptune, this would be like the blue spot, which is just like Jupiter's red spot. So it's a storm, only on a different planet. So Neptune has its own storm as well. All right, here's your next set of review questions. Answer these about the Jovian planets or the gas giants, and then hit play, and I'll continue and finish up this lesson. All right, we're going to talk about a couple more things, and then we will wrap things up. So here's Pluto. Pluto used to be considered a planet. Now it is classified as a dwarf planet. It has its own moon named Charon. So Pluto is about the size of our moon, but has its own moon that goes around it, which is named Charon. It is the only planet, or what was a planet, that we have not visited in a spacecraft. Not manned, obviously, but computerized spacecraft. Was a planet, was the smallest. It takes almost 250 years for Pluto to go around the sun once, which is pretty nuts. And then a day lasts for just about a week, just under a week for a day on Pluto. Those are some fast facts on Pluto. All right, our last little bit. We're going to talk about eclipses. So we had a solar eclipse a couple years ago. A total solar eclipse, which is what we witnessed, is what we saw. And so it's not noticeable until the sun is 90% covered. That's when you start noticing it getting darker. And then at 99%, that's what we saw, was when the light on the horizon over here looked almost like dawn or dusk. The longest duration for an eclipse is about 7.5 minutes. I think ours was around 3-ish. We didn't quite get that, but we still had a really cool view, really cool experience. And then at any one location gets one solar eclipse, total solar eclipse, once every roughly 360 years. So the chance of another solar eclipse happening here in your lifetime for sure, is slim and none. There will be something that happened, just not in here in Nebraska, specifically Dawn from Nebraska. And when these happen, it can kind of mess with local animals and wildlife, that they can think it's becoming nighttime temporarily and go into kind of their sleep mode, and all of a sudden the sun comes back and they have to wake back up and it's daylight again. But this can also drop the temperature 20 degrees or more. So if you think back, it did get colder while the eclipse was happening because we're not getting this light and energy from the sun. But that is a solar eclipse. I would love to see another one sometime in my life, but we'll see if that happens. This is different from a lunar eclipse. So in a solar eclipse, we have the sun is blocked by the moon, which creates a shadow on Earth. In a lunar eclipse, we have the sun, which gets blocked by the Earth, which casts a shadow on the moon. So lunar eclipse happens when the moon passes through the Earth's shadow, which is what that's kind of showing you. This only happens when you have what is a full moon. So a full moon gets blocked by the Earth. And these can last for multiple hours. Because the Earth is so much bigger and creates a bigger shadow, a lunar eclipse can last for a very long time. And then anybody on, so if this is the Earth, anybody on this side of the Earth can see a lunar eclipse happening over here. Because the moon is on this side and everybody over here can see that moon. So an entire half of the country, half of the planet can see a lunar eclipse, whereas only a small portion gets to see a solar eclipse at a given time. But those are lunar and solar eclipses. And here are your final review questions. Make sure you can answer these, and I look forward to talking about more astronomy topics with you as we continue this unit.